Welcome all. In this lecture, we will discuss about the free particle. The free particle problem is the simplest one-dimensional problem. It corresponds to Vx is equal to 0 for any value of x. So if the potential Vx is equal to 0 for any value of x, then we can write the Schrodinger equation as minus h cut square by 2m d square psi by dx square is equal to E into psi. So we can rewrite this equation by placing the expression from the right hand side to the left side, that is d square by dx square plus k square into psi is equal to 0. Here the k square is equal to 2m e by h cut square, where k is the wave number. Now the most general solution to the equation, this one, that is equation 4.5, is a combination of two linearly independent plane waves. That is, we can write psi plus x is equal to e to the power ikx and psi minus x is equal to e to the power minus ikx. So the full solution will be psi k is equal to a plus e to the power ikx plus a minus e to the power minus ikx. So this is the full solution for equation 4.5, where a plus and a minus are two arbitrary constants. The complete wave function is thus given by the stationary state. Stationary states means, suppose if we consider the time, you see in the previous equation we have not considered time and we have written as psi kx. But if you consider the time factor, then we can rewrite the above equation in this way, that is psi kxt is equal to a plus e to the power I kx minus omega t plus a minus e to the power minus ikx plus omega t. So we know that this omega, there is a factor omega here. We know that E is equal to h cut omega. So omega is equal to E by h cut, that is equal to h cut k square by 2m. So if you write omega is equal to in this way, then what will happen, that is this equation, in this equation we are replacing omega by this term, that is omega is equal to E by h cut is equal to h cut k square by 2m, because you see here k square is equal to 2m E by h cut square, we have used this expression. So omega, that can be expressed as h cut k square by 2m. So you see here, that is omega has been replaced by this expression. So equation 4.7 is the solution considering both position and time. Now the first term, this is the first term, we are writing this as psi plus xt and this is equal to a plus e to the power I kx minus omega t. What is the implication of this equation? This equation represents a wave traveling to the right, while the second term psi minus xt is equal to a minus e to the power minus I kx plus omega t, where psi minus xt is equal to a minus e to the power minus I kx plus omega t, and that actually represents a wave traveling to the left. So this is the combination of two waves. One wave travels to the right and another wave travels to the left direction. So this is the combination of the two waves. Now the intensity of these waves are given by a plus l whole square and a minus l whole square. So this is the intensity of the wave, and we know that intensity is the square of the amplitude. This is the amplitude for the one wave and a minus is the amplitude of another wave. As intensity is the square of the amplitude, so the intensity is a plus square and a minus square respectively. We should note that the waves psi plus and psi minus are associated respectively with a free particle traveling to the right and to the left with well-defined momenta and energy. The momenta P plus minus is equal to plus minus h cut k, and E plus minus is equal to h cut square k square by 2m. Because we are solving the Schrodinger equation, and for this purpose we know that there should be some well-defined momenta and energy. What is the value of the momenta? P should be h cut k and E should be p square by 2m or h cut square k square by 2m. These are the solution of the Schrodinger equation. So we'll comment on the physical implication of this in a moment. Since there are no boundary condition, we are considering the free particle, and there are no boundary conditions. That means there are no restrictions on k or on energy E. All values yield solutions to the equation. So the free particle problem is simple to solve mathematically, yet it presents a number of physical subtleties. Let us discuss briefly three of these subtleties. First, the probability density densities corresponding to either solutions. Suppose we know that probability density is equal to psi star into psi, or we can write that is mod of psi xt square. So the probability density P, that will become ultimately mod of A plus minus L whole square. So this is the value of the probability density. Now you see in the right hand side, that is a constant actually. The right hand side is a constant, and they depend neither on x nor on t. So the probability density does not depend on position or time. Why? Because this is due to the complete loss of information about the position and time for a state with definite values of momentum P is equal to h cut k and energy E, that is equal to p square by 2. I am again repeating the sentence. That is, we have shown that the probability density does not depend on position and time. Why? Because as we are solving the Schrodinger equation, and we have considered a free particle which has a well-defined momenta and energy. As the momenta and energy, they are well defined, that is why we are not obtaining the well-defined values of position and time. Why? Because this is a consequence of Heisenberg's uncertainty principle. When the momentum and energy of a particle are known exactly, then what will happen? That is, uncertainty in the momentum becomes 0, delta P is equal to 0, and uncertainty in the energy delta E, that is also 0. There must be total uncertainty about its position and time. So as delta P is equal to 0 and delta E is equal to 0, so what will happen ultimately? Delta X becomes infinity and delta T becomes infinity. That means there will be total uncertainty about the position and time. Another subtlety, that is second subtlety, pertains to an apparent discrepancy between the speed of the wave and the speed of the particle it is supposed to represent. The speed of the plane wave psi plus minus xt is given by v is equal to omega by k. We can write omega by k, that is equal to E by h cut k. Again, from the relation that we have already discussed, that is E by h cut is equal to h cut k square by 2m. From that relation, ultimately this becomes h cut k by 2m. This is the velocity of the wave or v wave. On the other hand, the classical speed of the particle is p by m. This is the velocity of the particle, p by m, but p is equal to h cut k, so h cut k by m. So you see, that is from this two equation we can say that v of classical particle is equal to 2 into v wave. So ultimately, what is the meaning of that? This means that the particle travels twice as fast as the wave that represents it. Thirdly, the wave function is not normalizable. So if we perform the integration, that is minus infinity to plus infinity psi star psi into dx, So this will give you mod of a square integration of dx from minus infinity to plus infinity. So that means it is infinite. That means the wave function is not normalizable. So ultimately we can conclude that is psi plus minus xt, that is the solutions of the Schrodinger equation, are thus unphysical in nature. Physical wave function that must be square integrable. So the problem can be traced out to this: a free particle cannot have sharply defined momenta and energy, because as we have assumed the particle has sharply defined moment and energy, that is why there are some discrepancies. So the problem can be traced out, that is, a free particle cannot have sharply defined moment and energy. So in view of the three certainties that we have obtained above, the solutions of the Schrodinger equation that are physically acceptable cannot be plane waves, because we have considered the solution of the Schrodinger equations are plane wave in nature. So that is not acceptable. Instead, we can construct physical solutions by means of linear superposition of plane waves. And we have already discussed about the superposition of plane waves. When there is some superposition of plane waves, then what we obtain, that is the wave packet. So the structure of the wave packet is like this: psi xt is equal to 1 by 2 pi minus infinity to plus infinity phi k e to the power I kx minus omega t into dk. This is the structure of the wave packet, or the equation of the wave packet. Here phi k is the amplitude of the wave packet and is given by the Fourier transform of psi x comma 0. So phi k is equal to 1 by root 2 pi minus infinity to plus infinity psi of x comma 0 e to the power minus I kx into dx. And the wave packet solution cures and avoids all the subtleties raised above. First, the momentum, the position and the energy of the particle no longer known exactly. Only probabilistic outcomes are possible. And we have already shown that the wave packet and the particle travel with the same speed. Vg is equal to p by m, that is the group velocity of the whole packet. And third, the wave packet, that is this equation, is normalizable. So we can summarize in this way that a free particle cannot be represented by a single plane wave. It must be represented by a wave packet. So this is the end of the lecture, and for further discussion I refer you the book of NJTD, the Quantum Mechanics Concepts and Applications. So thank you all for listening the lecture.